Welcome back to Spice. In this session, we'll talk about the PSV. Of course, we have uploaded videos on PSV basics and PSV design, but this is more on the question and answer specific to the engineering design. See, one of our Spice member has actually raised this concern, or rather the questions. So when he started sizing the PSV, he has some queries. So this is for him. This is for him. Okay. And of course, if any of you are interested or come across these queries, this will also benefit you. That is the intent of this. Okay. So what are all the questions? Okay. First question, what I received from him is PSV body material selection. For PSV body material selection, we are selecting based on the outlet piping class. The reason why? What is the reason? See, friends, I am repeating again. For PSP body material selection, we are selecting based on the outlet piping class. What is the reason? Okay, there are many reasons actually. One is the compatibility. Okay, so what is this compatibility? See, we have to ensure that the material of the PSV and the outlet piping are compatible. Okay, which helps to prevent issues such as corrosion, which can compromise the integrity and safety of the system. So this is the first answer. Okay. So again, I'm repeating the question. For PSV body material selection, we are selecting based on the outlet piping class. So one is the compatibility. We need to ensure that the materials of the PSV and outlet piping are compatible and helps to prevent issues such as corrosion. Okay. Right. Then temperature and pressure conditions. Okay. See, friends, if you take the outlet piping class, it often reflects the temperature and pressure conditions, right? Yes. So matching the PSB body material to these conditions ensure that the valve can withstand the same operational stresses. You got it? Yes. So temperature and pressure conditions also we need to take into account. Again, I repeat, the outlet piping class, outlet piping often reflects the temperature and pressure conditions that the piping will encounter. Obvious, right? Yes. So matching the PSB body material to this condition ensure that the valve can withstand the same operational stresses. That's a point. Okay. Then third item, safety and reliability. Okay. So using the material that are consistent across the system, helps to maintain the overall safety and reliability of the pressure relief system. Okay. So this uniformity, meaning this matching actually reduces the risk of material failure under extreme conditions. So that is the one of the reason, safety and reliability. Again, I repeat, friends, safety reliability, right? Using material that are consistent across the system helps to maintain the overall safety and integrity, reliability of the pressure relief system. So thereby reduce the risk of material failure under extreme conditions. Then regulatory compliance. Of course, industry standards and regulation often says that the materials used in safety critical components like PSVs must meet the specific criteria. What is that? Aligning the PSV body material with the outlet piping class helps to ensure the compliance with these standards. Okay. So that is also one of the reason. Okay. You got it right? Okay. So this is the first question. Right. Then second question, what he has asked. When selecting the insulation for a pressure safety valve, okay, it is important to consider the specific conditions and requirements of both inlet and outlet piping. Why? That is the reason. Again, I repeat the question. When selecting the insulation for a PSV, it is important to consider the specific conditions and requirements of both the inlet and outlet piping. Okay? Why? Okay, again, I repeat the same thing. Temperature, okay, sorry. Yeah, temperature consideration. Okay. So, for example, the insulation should be chosen based on the temperature condition of the piping it is protecting, right? Obvious, right? Yes. So, if the inlet and outlet pipes have significantly different temperature, this is the point. If the inlet and outlet pipe have significantly different temperature, you may need to select insulation that can handle the higher of the to temperature to ensure the safety and efficiency. This is the point. So the point is why it is important to consider specific condition and requirement of both inlet and outlet. So one aspect is the temperature consideration. So here, when we talk about temperature, the insulation should be chosen based on the temperature condition of the piping it is protecting. So if the inlet and outlet pipe have significantly different temperature, we may need to select insulation that can handle a higher of the two temperature to ensure the safety and efficiency. This is one of the aspects. Then second is the material compatibility. Ensuring the material is compatible PSV body and the piping material. Okay. This will help any chemical reactions or degradations over time. So this is also we need to focus on material compatibility. Then thermal performance. Friends, if you talk about thermal performance, the insulation, it should provide adequate thermal resistance to maintain the desired temperature within the PSV and the connected piping. Okay. So that is why it is very crucial for maintaining the integrity and performance of the PSV, meaning thermal performance. That is the one of the reason actually. Okay. Right. Then the fourth one obvious is the regulatory compliance. Of course, we have to follow the industrial standard and regulation, for insulation and insulation practices. Okay, thereby meeting the performance requirements. So that is the reason. Then, of course, operational. Consider the operational conditions such as pressure, environmental exposure, and also the thermal cycling. So the insulation should be robust enough to withstand this condition without deteriorating. Okay, so that is why we always consider both the inlet and outlet piping. Okay, so these are the scenarios. Okay, so what I can say apart from this, okay, to sum up in this for this question, so it is recommended to match the insulation type to the inlet piping if the inlet conditions are more critical. This is the point. Higher temperature or more aggressive environment. However, if the outlet conditions are more demanding, then insulation should be based on those conditions. Okay, right? You got it, friends? Right, right. This is about this. Okay. So the point is, if the inlet conditions are more critical, you go with that. Okay. If outlet conditions are more demanding, then you go with that. So this is about the second question. Third, very important question. How to calculate this number of valves required for LNG tank based on the discharge flow? How to calculate the number of valves required for LNG? We are talking about PSV based on the discharge flow. See, there are many procedures actually. What we can say, what I can say is here, we need to come out with the first determine the total discharge flow rate. We need to determine the total discharge flow rate. How to calculate the total discharge flow rate? So this is typically based on the maximum expected flow rate during an emergency or operational scenario. So first we need to determine the total discharge flow rate. Okay. So this is typically based on the maximum expected flow rate during the emergency or operational scenario. Then we need to select the valve type and size. Okay. So choosing the appropriate type and size of the valve that can handle the calculated flow rate, right? Yes. So this involves, various factors actually, such as, the CV, valve coefficient, pressure drop, specific characteristics of LNG, all these actually. So that is the second step. Then third is very important. Calculated the flow capacity of each valve. So how to calculate this? We have a flow coefficient, right? So using the valve flow coefficient CV and the pressure drop across the valve, we can calculate the flow capacity for each valve. So what is the formula? Flow capacity, that is Q is equal to, not Q, yeah, Q is equal to CV times square root of delta P by rho. So where Q is the flow rate and delta P is of course the pressure drop and rho is the fluid density. So this is the formula we need to use to calculate the flow capacity of each valve. Okay. Then determine the number of valves needed. That is very important. How to get this number of valves needed? We need to divide the total flow discharge flow rate. What are we calculated, right? The total discharge flow rate, right? So we need to divide that by the flow capacity of the single valve. Whatever we have calculated here, right? So flow capacity of a single valve to determine the number of valves required. Okay. And ensure to account for any redundancy or safety factors in line with the standards. You got it, friends? So basically, these are the points actually. First, we need to determine the discharge flow rate, then select the valve type and size. So, and calculate the flow capacity using the formula Q is equal to CV times of square root of delta P by rho. Then determine the number of valves needed. How? Divide the total discharge flow rate by the flow capacity of a single valve. Okay. Then consider the valve arrangement. See, meaning we need to decide on the valve arrangement, whether it's a parallel or series based on the system design and operational requirement. So here we can say the parallel arrangement are common to ensure redundancy and handle larger flow rates. Okay. Then of course, finally, the compliance with the standard. Ensure that we have to ensure that the selected valves and their arrangement all comply with the relevant industry standard and regulations. Okay. So these are the procedure actually to calculate this number of valves. So specific to his question, how to calculate the number of valves? So basically, you have to use this formula, flow capacity, and we have to get the total discharge flow rate and divide by the flow capacity to determine the number of valves required. So this is the summary of this question. Okay. Then what else? Yeah. One more very specific question. In a fire scenario, a fire case scenario of a PSV, using the design temperature, this is the point, instead of the relief temperature, for sizing is recommended. Okay, why? Okay, in a fire case scenario, okay, for PSV, using a design temperature instead of a relief temperature for sizing the valve is recommended. This is the point. Using a design temperature instead of relief temperature is recommended. Using API 526, right? So the why he has asked why. Okay, again I consider these aspects. Material selection. Okay, the design temperature, is used to ensure the material selected for the PSV can withstand the maximum temperature the system might encounter during a fire. Okay, what for? This helps in maintaining the integrity of the valve under extreme condition. You got it? So that is the material selection. Again, I repeat. So if you use the design temperature, this is used to ensure the material selected for the PSV can withstand the maximum temperature the system might encounter during a fire. Okay. Then safety and reliability. During the fire, actually, the actual temperature of the fluid might exceed the normal operating condition, right? So by using the design temperature, which is typically higher, we can ensure that the valve will function correctly and safely even in the worst case scenario. You got it? Yes. So that is the safety and reliability point of view. Then, of course, the regulatory compliance. As I highlighted earlier, the API 526, right? So, API 526 suggests using the design temperature to ensure the valve material and construction are suitable for the highest possible temperature. So, to meet the safety regulation and industrial standards. Then another point is preventing catastrophic failure. In a fire scenario, friends, if the PSV is critical in preventing overpressure, right? Obvious, right? Thereby preventing the potential explosion, right? So using the design temperature ensure that valve will not fail due to thermal stresses, thus providing a reliable safety mechanism. So that is about this question actually. So these are some questions I received from him, and this is just for him only exclusively. If any of you interested also, you can watch, friends. Next, we'll see some other interesting video, which is common for all of our viewers. Thank you. Take care. Bye-bye.